Hello, Matthews, Gatos here. In this video, I want to review solving radical equations with one root. So I have two questions to do that, and they're pretty cool questions. So in this one here, I like this question because it's a bit of a twist. So it's not asking you to necessarily solve the radical equation, it's asking you to find one step in the process of solving the equation. So when we're solving this radical equation, at some point in our solution, we end up with this quadratic, and that's what they want to know, not the solution, but the value of b and c in that quadratic. So let's go ahead and solve and see what we come up with. So because I'm not actually solving the question, I won't worry about my restrictions. I'm just getting to the point of the quadratic. So first thing I'm going to do is isolate my radical so I can square both sides. So 3 take away 3 is 0. And on this side here, I'm left with x plus 3 equals the root of x plus 6. So now that my root is isolated, the only way to get rid of a square root is to square. And I have to do that to both sides to be fair. So squaring and square rooting are inverse operations, so they cancel each other out. And then I want you to remember, when you have a binomial, I want you to write that out 2 times so you don't make a silly mistake. So left side, x plus 3 times x plus 3, right side, just x plus 6. So applying my distributive property, I have x squared plus 3x plus 3x plus 9 equals to x plus 6. So let's continue this up here so we have some more room. I'm going to group my like terms on this side here, so 3x and 3x. And then I'm going to set the equation to 0. So to do that, I'm going to subtract 6 from both sides. Sorry, x from both sides. I was looking ahead because now I'm going to subtract 6 from both sides. So here, x take away x is 0. 6 take away 6 is 0, so it's equal to 0. And I have x squared. 6x take away x is 5x. 9 take away 6 is 3. So I always like to come up to my template and write my equation right underneath it so I can properly line everything up. So I can see here x squared, that looks good, and the number in front of x is your b value, and the y-intercept or lonely number is your c value. So the answer to this equation would be 5, 3. Okay, another great question with a bit of a twist. It's asking you to take this radical equation and not find the solution, but find the extraneous solution. So I really like this question. So we're going to go ahead and solve it. Because I am solving it to find my extraneous root, I'm going to state my restrictions, and it's a great chance for me to review that with you. So remember, we have double trouble here because we have variables on both sides. The first restriction is that 4x plus 3 has to be greater than or equal to 0. Let's solve that. So subtract 3 from both sides, divide both sides by 4. So my first restriction is that x is greater than or equal to 3/4. My second restriction is on the left-hand side of my equation. So on the right-hand side, I have a positive principal root, and it's equal, so I know whatever the value of 2x is, it has to be positive. That's the only way the equation will balance. So I have another restriction that 2x has to be greater than or equal to 0. So divide both sides by 2, and I have x greater than or equal to 0. So I have two restrictions. They're pointing in the same direction. Let's see if we can combine them as one restriction. So I'll just draw a little rough sketch of a number line. I know -3/4 is less than 0. I'm just going to use different colors to show you each restriction. So here x is greater than -3/4 or equal to. So it goes like this and forever on that way. Then let's look at my other restriction, which is x greater than 0. So here's 0 and it's all above. So we're looking to see, can we combine these as one restriction? I look at the overlap and I see that x greater than or equal to 0 covers both restrictions. So this will be my overarching restriction. So I know when I look for an extraneous root, I'm going to make sure, I'm going to check my solutions to make sure x is greater than or equal to 0, and if there's a solution that's not, that will be my extraneous root. So let's square both sides since my radical is isolated. The opposite of square rooting is squaring. These are inverse operations, so they undo each other. On the other side, 2x squared, I'm just going to be super cautious and write that out twice. The reason I do that is because I want you to remember that the 2 and the x are squared. So 2 times 2, 4, x times x, x squared equals to 4x plus 3. So I'm going to set this quadratic equal to 0. I'm going to subtract 4x from both sides and subtract 3 from both sides. So that's all gone. So I'm left with 4x squared minus 4x minus 3 equals to 0. Let's make that a little bit bigger for you. Okay, so now we have to factor. So let's review factoring. I'm looking for two numbers that multiply to 4 times negative 3, which is negative 12, and add to negative 4. So two numbers that multiply to negative 12, but also add to negative 4. So looking at my factors, and you can do this on the calculator, I know that the factors of 6 and 2 are 4 units apart, so I know it must be 6 and 2. Since I add to the negative, the bigger of the two has to be negative. So I'm going to go ahead and factor this. First term goes here. Last term, oh, what have we got going on there? There we go. Last term goes here. And then the middle term, negative 6x and 2x go here. So to factor that, greatest common factor here is a 2x. Greatest common factor here is a 3, but take your negative leading coefficient out. Greatest common factor here is 2x. Greatest common factor here is 1, and my leading coefficient is positive. Okay, so I know it factors as 2x plus 1 times 2x minus 3 equals 0. So set each factor equal to 0, and then we're going to find out which one the extraneous root is. So here, subtract 1 from both sides, and then divide both sides by 2. Here, add 3 to both sides, divide both sides by 2. So I get a solution of x equal to 3/2 or x equal to negative 1/2. So remember your restriction, x has to be greater than or equal to 0, which means this is your extraneous root. So x cannot equal to negative 1/2. So going up here, my extraneous solution is x equal to negative 1/2. So I see my negatives line up. So the value of p is 1/2. Or as a decimal, I would also accept 0.5. So those are really two great questions with a little twist on how to solve radical equations with one root. So I hope this review helped, and I look forward to seeing you for the next video.